All right, so we're going to be doing sum and difference identities today, so I hope you have those handy for you to look at. And I'm going to show you again what you were supposed to do for this first quiz on those bottom 5 problems, because some of you still didn't do it right. So I'm going to go into this sheet. So sine of 135, we're going to do it the way you should do these. What do you notice about the top 3 angles up there with your unit circle? They're all on the unit circle, right? If you look at the bottom, the next 3 for the next notes, those are not on the unit circle. But we're going to use numbers on the unit circle for the ones that don't have numbers on the unit circle. And you notice that this says find exact value. That means if you write a decimal down, it will be wrong. You're not allowed to have any decimals. You must do calculate and do some math to get these correct. So tangents are the hardest ones to do unless they're on the unit circle. So I'm going to do the unit circle with these 3 first because this will show you, yeah?
I don't have that together. I think I have the homework tomorrow either.
Did you give her one?
Yeah.
Oh, okay. All right, so here's what you're supposed to do on those last 5 problems on the quiz, because we've already done this stuff. You're supposed to look at your unit circle, and you are supposed to know that the sine of theta on the unit circle is the y value, the cosine of theta on the unit circle is the x value, and the tangent on the unit circle is y over x. You're supposed to know that. So you go to 135 degrees, which is right here on your unit circle, and the ordered pair you get right there is negative radical 2 over 2 and radical 2 over 2. This says sine. So you know sine is y, so you go to the y value, and this is your answer. So this will be radical 2 over 2. 210 degrees is right here. And if you go to 210 degrees, the ordered pair of these is negative radical 3 over 2.5. And you're supposed to know that cosine is the x value. So here's the x value, so that's the answer for this. Then you are supposed to go to 300 degrees, which is right here on the unit circle. And the ordered pair right there are these 2 things. And you are supposed to know that tangent is y over x. So this is supposed to equal negative radical 3 over 2 divided by 1/2. Now you cannot leave a complex fraction. So you're supposed to know that you're supposed to multiply by the reciprocal of the bottom. So all these reduce out, and this just equals negative radical 3. Now that's what you were supposed to do on your quiz. Some of you did not do that, even after I showed you how to do the sine of 30. So that's what your quiz is like. Now, if you ever have numbers on the angles that are on the unit circle, I would never do what I'm about to show you. And I'm only going to show you one way that you're supposed to use. You can use sum and difference, and I'm going to leave the answer for this one right here to show you get the same answer. Okay? So we already know that this has to equal radical 2 over 2. That's the answer for 130 sine of 135. But if you're going to use sum or difference, and you can use either one, but you got to find numbers on the unit circle. So I hope you all have your unit circle still right there. Can anyone find me 2 numbers on the unit circle that will either add up to 135 or subtract and give you 135? It can be either way. There's more than one way to do these. Okay, there's more than one way, and they all give you the same answer. Can anybody find 2 numbers on the unit circle that either add up to 135 or have a difference of 135? What do you got? 90 plus 45. So we are going to rewrite this as the sine of 90 plus 45. So is this a sum or difference problem? This is a sum problem. So your identity that's on your sum for sine of u plus d says this. It says it's the sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. That's what you got for that identity. So this is my u, this is my v. So I'm supposed to rewrite this in this form. So I get sine of 90 cosine of 45 plus cosine of 45 times sine of 90. Oops, I wrote back these two backwards, my bad. The u goes first, so this should have been a 90, and this one over here is a 45. My bad. That's 90, this one's 45. Now I go to my unit circle. We are supposed to know that 90 is right up here, and the ordered pair up there is 0, 1. 45 degrees is right here. And the ordered pair on your unit circle are these two. So what we're going to do is we're going to do what we did a second ago, but we're going to plug them in for these values. So the sine of 90 is the y value at 90, so we put a 1 in for that. Cosine of 45 is this x value at 45 degrees, so we put in radical 2 over 2 for that. Then we get a plus sign. Then we get cosine of 90 is the x value right here at 90, which is 0. And the sine of radical 2 over 2 is the y value, which is the sine of 45, the y value down here, that one. Now, what's 1 times radical 2 over 2?
2.
And what is 0 times anything?
0.
So this is my answer. So you can see we get the same answer by doing the sum, and we would have got the same if we would have taken, let's say we would have taken 180 minus 45. We'd have done the difference. If we'd have done 180 minus 45, we still would have got radical 2 over 2. Okay, but this is, we're practicing sum and difference. But again, on the test, on the quizzes, if you have an angle that's on the unit circle, don't do sum, difference, half, double. Don't do those. Just take the answer like I did the first 3 problems I did. Because all the rest of them take longer. What's your question, sir?
On that quiz, there was one is like cosine 11 pi over 6, and I was confused on how to find the
It's
pi.
on your unit circle, dude. Remember what pi is in degrees?
Oh, I see.
It's 330 degrees.
Okay.
Okay, it's on there.
Yes.
All right. Now we're going to come down here and do these, and these are not on the unit circle, so you must use one of those new identities. So we want to find 2 angles that are going to add up to 255 on your unit circle, or have a difference of 255. I need somebody besides who told me the last one. I'm trying not to say names because I'm not supposed to put names on videos. So I want somebody else to tell me 2 angles that are on the unit circle that will add to 255 or subtract and give you 255. 15? Is 15 degrees on there? No, so that won't work. I need 2 angles on your unit circle. Timmerman? 225 minus 30. So if I take 225 minus 30, is that what you said?
It's plus.
Oh, plus 30, my bad. Plus 30. That works out, right? Okay, so it turns out, oops, I put it in the wrong place. It's supposed to be down here, my bad. So I'm going to do the same problem I did a second ago with different angles. So I got the sine of 225, cosine of 30, plus cosine 225, sine of 30. So you pull out your unit circle. You go to 225 degrees, which is right down here. And the ordered pair at 225 is negative radical 2 over 2 and negative radical 2 over 2. You go to 30 degrees, which is right over here. And the ordered pair right there is radical 3 over 2 and 1/2. So sine of 225 is this y value right here. So this is negative radical 2 over 2. Cosine of 30, I go over here, the cosine is this part right here, so this is radical 3 over 2. You put a plus sign, keep that plus sign right there. Go over here, the cosine of 225 is this x value right there, which is negative radical 2 over 2. And the sine of 30 is this y value over there, which is 1/2. How many are thumbs up so far where all that comes from? Show me. Thumb up or down? If it's down, if you don't know, I want it down. Okay, going on. Now I got to multiply. How do you multiply fractions? Okay, so what's negative radical 2 times radical 3? Negative radical 6. What's 2 times 2? Over here, what's negative radical 2 times 1? Negative radical 2. And what's 2 times 2? What happens real nice with the denominators? They're a common denominator. So we're going to put both numerators over the common denominator, and this is my answer right here. You cannot add radicals that aren't the same. Just to remind you of how radicals add, if you have radical 2 plus radical 3, you can do nothing with that. If you have 2 radical 2's plus 3 radical 2's, you can add the coefficients of the radicals, and that's 5 radical 2's. Okay, so radicals are kind of like variables. They don't change when you add and subtract. They do change when you multiply. You can multiply what's in a radical by what's in a radical. Okay? All right, now I want to show you that you can be 100% sure you're right on this problem. So if you take your calculator, does anybody remember what we were trying to find? What are we trying to find on this problem? I can't hear you. Yeah, aren't we supposed to find the sine of 255? So you got to make sure that your calculator is in degrees. I'm going to show you that you should know before you turn in your test or your quiz whether or not you're right on these. So I'm going to type in the sine of 255, and I'm going to get that answer. Now, what did I say that equaled? The sine of 255 equaled what? This. Didn't we find this at the bottom? Negative radical 6 minus radical 2 over 4? Yeah. So I'm going to show you that if I'm going to hit alpha y equals 1 to get a fraction. And I'm going to take in negative radical 6 minus radical 2. Oops. I got to go back over here and do this again because I forgot to arrow over. You got to arrow out from under that first radical. Minus radical 2 all over 4. Hit enter and look at my decimals. Okay. I forgot to do the first thing. Okay, so we'll hit enter again. There we go. Is that equal to the top thing? Hello? Is the sine of 250? Oh, I didn't do this. I got to go back up and do that, and I did it in radians the first time, didn't I? So I got to do 255 again also. Okay, there we go. Are they the same? Yeah. You guys should have said when you had a different decimal that I was in radians right then when I did 255. Did you guys do it with me? I hope so. You should practice this. You see the two decimals are the same? That means we're right. All right, we're going to go on. And if you want me to check the next one, I will, but I'm going to go on and do cosine of 75 now. Okay? How many are thumbs up on this thing? I can't see everybody. I need everybody. Okay, we're going to go on to the next one. Now I need somebody to find me two angles that either add up to 75 or have a difference of 75. What do you got? 45 plus 30. So we're going to get cosine of 45 plus 30. Now, since we did two sum ones here, I'm going to make you find a difference. It's 195, so we do a difference one. Now, if you look at your identity, the cosine of u plus v is going to equal the cosine of u, the cosine of v plus, or sorry, minus, because this sign is always different or whatever that sign is, sine u sine v. So I hope you see that u is 45 and v is 30. So I'm going to get cosine 45, cosine 30, minus sine 45, sine 30. I kind of wish I hadn't taken off my unit circle now, but I already had these up there, I think. So 30 degrees is right here, and the ordered pairs radical 3 over 2, 1/2. 45 degrees is right here, and the ordered pairs there are both radical 2 over 2s. So the cosine of 45 is that x value, so this is radical 2 over 2. Cosine of 30 is this x value, which is radical 3 over 2. Minus the sine of 45 is that y value, which is radical 2 over 2. And sine of 30 is that y value, which is 1/2. I'm going to multiply these out, so I'm going to get radical 6 over 4 minus radical 2 over 4. And this is radical 6 minus radical 2 all over 4. So you can plug that into your calculator again. You can plug in this cosine of 75. You can plug this in, and you can see those are both same decimals. Anybody want me to do that again? Anybody? Yeah.
Yeah.
Okay, so I'm going to do it on the calculator. I'm going to show you that those two things are the same. So I want cosine 75. Then I'm going to take alpha, y equals 1 to get a fraction. And I want radical 6 minus 2. Minus radical 2 all over 4. They are identical, so I know I'm right. Question. So when you guys are done with this quiz and test, you guys should know if every one of these are right or not. Because you're going to have more time that you can go back and check them. I don't think they take the whole hour if you have a clue what you're doing. All right, the next kind is the hardest kind. Okay, so let's see. When you do tangents, they are the hardest. Now, do you guys remember what I told you about tangents, what I would use in tangents? What I would make? I would make triangles because they're easier with tangents. I think you want to see both ways? Okay, I'm going to do unit circle and triangle, and you'll see triangles way faster. And it's not as complicated, although this one's going to be hard anyway. Okay? So, and we're going to do a difference of 195 for tangent. Does anybody have two numbers that'll give me that? All right, so if we take tangent of 240 minus 45, that will give me 195. So you guys like me writing the formula up here first so you can see where I'm getting it from?
Yeah.
All right, so I'm doing the tangent of u minus v, which on the formula sheet says it's the tangent of u minus the tangent of v all over 1 plus the tangent of u times the tangent of v. So this is my u, this is my v, so I'm going to plug those in, and that's going to be the tangent of 240 minus the tangent of 45 all over 1 plus the tangent of 240 times the tangent of 45. Anybody got a question so far? Now on tangent ones, what I'm going to do is I'm going to find, I'm going to come up here to 45 degrees, and I'm going to find the tangent of 45 first because it is really sweet. I hope you all know that tangent of an angle is the y value divided by the x value. Now this is the harder way in my case, but 45 one's easy. So when I do the tangent of 45 degrees, that's going to be radical 2 over 2 divided by radical 2 over 2, and somebody left that answer on the quiz today. It wasn't those exact numbers, but it was like that. You have to simplify this. What's radical 2 over 2 divided by radical 2 over 2? 1. So what I get to do is I get to come up here, and wherever the 45 is, I get to stick 1 in for the 45s. So all I've done is come up here and stick 1 in for those two places. Because that's what the tangent of 45 degrees equals. Everybody okay there? All right, now I'm gonna show you what you could have done that I think is faster. And that is to make triangles. So if you do a triangle at 45 degrees, you're all supposed to know that 45 degrees is in the first quadrant. And you're supposed to know that this is a 45, 45, 90. What do you know about the two legs in a 45, 45, 90? They're equal, and we always said they're ones. And this was radical 2, if you remember your specials. And now we're doing TOA. So that means the tangent of 45 degrees is equal to the opposite of the reference angle, which is that one over that one, which is 1. So do you see we get the same 1 that we plugged in over here? I hope you see that. Are we thumbs up that both those give me the same 1? I don't see thumbs. Now I think that's a little easier than using radicals. That's me. Although the next one we don't have a choice. So now we're going to go to 240. So 240 is right down here. And the ordered pair right down here is -1/2 radical 3 over 2. Now this is where the triangle comes in a little handier, although this one is not terrible. It is doable. I'm going to come up here then. So the tangent of 240 degrees is going to be y, which is radical 3 over 2, divided by x, which is -1/2. I have a fraction divided by a fraction. What do you do? Yeah?
Isn't it supposed to be negative radical 3?
Oh, it is negative. Thank you. Yeah, this is negative as well, and that's negative. Third quadrant, everything's negative. Thank you, sir. Okay, so what do you do when you have a fraction divided by a fraction? I'm listening. Keep the top the same and multiply by the reciprocal of the bottom. So I hope you see this 2 and this 2 reduce. What's a negative times a negative? So this is equal to just radical 3. So I come down here, and wherever the 240 is, I'm sticking in radical 3. Now, if I was doing a triangle at 240, you should know that that's down here in the third quadrant. And this is a 60-degree angle, because 240 minus 180 makes that 60. So this is a 30, 60, 90. Does anybody remember on the special 30, 60, 90 what the side is opposite the 30? It's the smallest one. 30 is the smallest angle, so the side opposite's the smallest one. What do we let that be in the 30, 60, 90? 1. It is 1. So this is 1. And the one opposite 60 is radical 3, and the hypotenuse is 2. And since we're in the third quadrant, these two have to be negative. So if I do TOA again with these, opposite over adjacent, I hope you see that the tangent of 240 is going to be negative radical 3 over -1, which is positive radical 3. I get the same thing that I did from y over x. But I think this way is easier on tangent. Not sine and cosine, but tangent. The triangles are easiest. So I've already got this plugged in. So when I simplify this thing over here, I get radical 3 minus 1 over 1 plus radical 3. So anybody have a question so far? Now, we got to do some math, because why is that not allowed for your answer? You're not allowed to have a radical in the denominator. How many terms are in the denominator? 2. Does anybody know what that nominal is called?
1.
Binomial. So we learned, we've done this many times, when you have a radical and a binomial in the bottom, you have to multiply by a certain kind of number to get the radical out. Does anybody remember the name of that number? It starts with a C. What? What'd you say?
That's right.
What'd you say? Coefficient is a number in front of a variable. That's a good C word for math, but that's not the one we're looking for. C-O-N. Next letter will give it to you. What?
Conjugate.
Conjugate. Conjugate. What is a conjugate? What is the conjugate of this denominator, 1 plus radical 3? Who can tell me that one? That's right. So we have to take, and we have to multiply this fraction by the conjugate over the conjugate of the bottom. Now, let's see if any of you can remember this. When you multiply conjugates together, what answer do you get? What? A difference of 2 squared. I'm going to remind you, I'm going to get rid of this circle here and remind you of this. In case you don't remember, we've done this multiple times. We were supposed to have learned a long time ago that if I take a conjugate and FOIL it with the, or take a binomial and FOIL it with its conjugate. Are we about done? These two things in the middle always cancel out and you get a difference of squares. So what that tells me is my denominator is going to be 1 squared minus radical 3 squared. That's what I'm going to get when I FOIL the bottom. The top part's harder, you have to FOIL it. Radical 3 times 1 is radical 3. Radical 3 times negative radical 3 is negative radical 3 squared. Negative 1 times 1 is negative 1. And then negative 1 times negative radical 3 is positive radical 3. Now we got more work to do here. Okay, so up here I want to add like terms. Radical, I'm going to do this real fast. Radical 3 and radical 3 is 2 radical 3. And I get to take this 3 out up here. Down here, I got 1 minus 3, so in the top you get 2 radical 3 minus 4 when you combine like terms, and the bottom's negative 2. So if I factor a 2 out of the top, I get this. And these 2's reduce, so you take radical 3 over negative 1 minus 2 over negative 1. So this ends up being a negative radical 3 plus 2. And you can write that as 2 minus radical 3 because we usually put the positive number first. So that's that problem. So go out and try to